Hi, today we're going to be talking about section 2.2, linear relations and functions. By the way, that's my favorite outfit, this section, 2.2. You get it? Sorry about that. We're going to be talking specifically about identifying linear functions, evaluating linear functions, what standard form is, and how we use that to find the intercepts in order to graph a line. So if we just look at some of these functions, we have linear functions versus nonlinear. Linear functions just mean that if you were to draw them on the graph, they make a straight line. Nonlinear functions don't. They make curves, or usually they're curved. So you can see the different forms. This first form, that 4x minus 5y equals 16, that's actually in standard form. The second one, x equals 10. Okay, x equals 10 will be a vertical line. Anytime it says x equals and then it's just a number, that's a vertical line. Okay, so it's not a function actually, so I guess this is kind of a, maybe we shouldn't call it functions, maybe we should say linear relationships, because x equals 10 is definitely not a function. This y equals negative 2/3 x minus 1, that's in slope-intercept form, and so is y equals 1/2 x. That's also in slope-intercept form. The intercept just happens to be 0, so it's kind of like having a plus 0 at the end of that. What I'd really like, what isn't on here is another that is fairly common, would be the horizontal line, like if we had y equals 2. So that's another one. Those are all very common lines that we'll have. As far as nonlinear lines, there's all kinds of different nonlinear lines, but here's just 4 examples. This first one's not linear because it has a y squared in it. The second one's not linear because it has the square root of x in it. This third one is not linear because it has an x times y in it. And this fourth one is not linear because it's a 1 over x versus just y equals x. So none of those are lines. So if we take a look at one ourselves, if we look at this, and really you're going to see it written like this, f of x equals 5 over x plus 6. Okay, that comes from this parent function here, the 1 over x. Anytime we have an x in the denominator over there, it's not going to be a linear function. Okay, so that one is not a linear function. So I want you to look at this g function here and hit pause and state whether you think it's a function or not and why. Okay. The fractions may have thrown you off a little bit, but it's really still in this form of y equals mx plus b. So yes, this is a line and it's in the form y equals mx plus b. Next we have evaluating linear functions. We're just going to go straight into an example with this. We have the growth rate of a Bermuda graph given by the f function 5.9x plus 3.25. If the grass is 50.45 inches tall, how many days has it been since it was last cut? So if we look at this function, f is really is the growth, well, the 5.9 is the growth rate, okay, and the 3.25 is kind of that starting position, where it's at. That's, if we were assuming this would be like where the lawnmower cuts it down to. So if we know that it's going to grow to 50.45, that'll actually be our f of x function. So if we write it out, we'll write it out as 50.45 equals 5.9x plus 3.25. Okay, and then if you remember, in order for us to get rid of addition, we have to subtract. So we subtract 3.25 to both sides, and we will get 47.2 equals 5.9x. And then the 5.9 is multiplying x, so to get rid of multiplication, we divide by 5.9, divide by 5.9. So x equals 8, so that's 8 days. Okay, so that was a little bit harder. Normally they'll ask you a question first that says something like, after this many days, how tall will the grass be? That's way easier. Like, let's say after 1 day, what would it be? We would just use the function f of 1. We'd put a 1 in place of that x. So we'd put a 1 in place of the x in the equation. So 5.9 times 1 is 5.9. And then it's plus 3.25. Okay, 5.9 and 3.25 make 9.15. And it must be in inches. Okay, so that's where you would go. Most of the time that's where you start. So we actually started with a harder problem. Okay, I want you to hit pause. Think about this. Is it reasonable to think that the growth rate can be maintained for a long period of time? Meaning, we just went to, that was 8 days. Well, let's talk about a year. Does it make sense that this growth rate would stay constant when we continue to grow at this rate? So hit pause, write down what you think about this, and then we'll talk about it. Okay, hopefully you said no, and maybe even some of you have done this, or at least seen, if you just look at wild grass outside, it's not like it continues to grow as tall as a tree. It kind of hits a point where it maxes out, and you'll see the seeds kind of pop out at the end. If you really let your grass grow for a long time, some seeds will come up them. But the growth rate will slow down, so this function wouldn't stay linear for a long amount of time. It would eventually hit a maximum point there that it won't grow much taller than. So hopefully you were close to that, and we can talk more about that if you'd like. Okay, we're going to change gears and get very specific and talk about what standard form of the line is. So this is, the form is in ax plus by equals c. Okay, but a, b, and c are all integer values, and a has to be positive. Okay, and b can't be equal to 0. So, well, neither can a, I guess. So you need a and b to be not equal to 0, but that is explanatory with the a greater than 0. And b cannot equal 0. Okay, here's an example. Write this equation in standard form and then identify a, b, and c. So we have the equation y, or 2y equals 4x plus 5. Well, we need it to be in ax plus by equals c, meaning we need the x's and the y's to be on the same side, and we need the 1's, the 5, to be on the other side, and that's our c value. Okay, so the first thing that we would do is move this 4x over. Okay, to move that 4x, we just subtract it over, because 4x minus 4x is 0, so we need to move that over, so that's negative 4x. Okay, so then let me get rid of that. So let's just rewrite what we have. We have negative 4x plus 2y equals 5. Okay. Standard form says that a has to be positive, though. Right now, a, the number that's with x, that's multiplying x, is a negative. So we need to multiply everything, this whole thing, by negative 1. That would change this to a 4x, then minus 2y equals negative 5. So it'll just change the sign on everything. So now we have it in a plus bx equals c, where a is positive, b is not equal to 0, so we are in standard form. Okay, we just need to identify what's a, b, and c. So a equals 4, b equals negative 2, and c equals negative 5. That is a negative sign there. Okay, I want you to hit pause and give this next one a shot. 3x minus 6y minus 9 equals 0. Go. Okay, hopefully you saw you've got your x and your y's on the same side right now, but our 1's, this minus 9, is not on the other side. So we need to move it over. So to get subtraction over, we add 9 to both sides. So we're at 3x minus 6y equals 0 plus 9 is 9. Okay, and our a value, which is the coefficient with x, is positive, so we are in standard form. So a equals 3, b equals negative 6, and c equals 9. Alright, one of the best parts about standard form is how nice it is to graph something. Okay, so if you look at this graph, we've got our x-axis and our y-axis. Okay, if we think about any value along the x-intercept, so we're talking about any value along here, the y value on our x-axis is always going to be equal to 0. So if we want to find out where it crosses the x-axis, which is called the x-intercept, we just need to plug in a value of 0 for y, and that will give us our x-intercept. Okay, so if we do that, we get 3x minus 4 times 0 equals 12. Again, we did that because we know the x-intercept, the y value anywhere along the x-axis is equal to 0. Okay, so that will always make that cancel. So we just now have 3x equals 12. So the 3 is multiplying, so to get rid of multiplication, we divide. X equals 4. Okay, so I go along here, I go 1, 2, 3, 4. I'm going to keep going up to 5 just to label it. 1, 2, 3, oops, I missed. That's right. 4, 5. You catch what I'm trying to get at here. 5, 1, 2, 3, 4, 5, negative 5 there. Again, I always label my axes. Don't ever, I will take off points if you don't label your axes, so make sure you always label. Okay, so we know that that's at the point 4, 0, or we just know that the x-intercept there is 4. Okay, in order to graph a line, I need 2 points. All right, so my second point would be, if we look at our y-axis, we know everywhere along this y-axis the value of x is equal to 0. So we plug in a 0 for x, we'd go 3 times 0 instead of x minus 4y equals 12. That will cancel, so we have negative 4y equals 12. That negative 4 is multiplying the y, so we divide to get rid of multiplication, and y equals negative 3. So I go to my y-axis, I go down to negative 3, which is right there. Okay, now I've got 2 points. I can take some sort of straight edge. Right now I'm using my cell phone. Hopefully it'll work. Okay, and there is the line 3x minus 4y equals 12. Okay, I want you to give this a shot now. Go ahead and find the intercepts for 2x plus 5y minus 10 equals 0, and then graph that line. Hit pause. Okay, well the first thing we need to do is get it into standard form, so we need to change it to 2x plus 5y equals 10. That's by just adding 10 to both sides to get the 10 to the other side of the equation. So now we're in standard form. Okay, if I'm trying to find the x intercept, I put in a 0 for y, and it makes that 5y cancel, or 5 times 0 is 0, so I just left with 2x equals 10, divide by 2, divide by 2, x equals 5. So I go over 1, 2, 3, 4, 5. Okay, there's my x-intercept. The y-intercept, I know the x value is 0, so 2 times 0 is 0, so I just have 5y equals 10. Divide by 5, divide by 5, y equals 2. That's 2. Okay, got my 2 points. I use my straight edge. And, oh, I missed him. That was a bad line. Sorry. Try to make yours actually cross. It's hard on the iPad. If you're using an iPad, it's hard to get it to be perfect. So that's close enough. You get the idea. But use a straight edge of some sort, not a piece of paper. It's way easier. Or if you have one of those good stylus that looks like a pen, you can use your iPad pretty well. Okay, bring any questions you have to class, and thanks.